Okay, so coming back, let's figure out how rectangular and polar coordinates, right, are connected. So if a point has a rectangular coordinate, x and y, and a polar coordinate, r, theta, then these coordinates are related as follows. So we have to remember the equation r squared is equal to x squared plus y squared, right? We've been using that a lot. And we've also know that our x is related to our cosine, but this time we're going to say r cosine of theta, where r really has always been 1, right? And y goes with sine, so this will be y is equal to r sine of theta, right? It also helps to remember that tangent is always our slope of anything. So if we remember our tangent, it's always the y over x, again, as long as x does not equal 0. So how can I kind of relate these two? So I said we've already kind of know about coordinates. And how can I relate these? So 1 and 30 degrees, how do I actually know that it's root 3 over 2 and 1/2, right? How do I know it comes from the unit circle? Okay, so let's think of it this way, right? So I'm going to prove that point right here. So 1 and 30 degrees. So 1 is my r, and 30 is my theta. So obviously I can't use this equation yet. Okay, so I have to plug in what I know. So I know this. So I'm going to say x is equal to, my r is 1 times my cosine of 30 degrees. What is my cosine of 30 degrees? Root 3 over 2. If I multiply those together, I get x is equal to root 3 over 2. I can do the same thing for my y. So again, y is equal to 1 times the sine of 30 degrees. So this will be 1 times 1/2. The 1/2 times 1 just stays as the 1/2. So this is my polar coordinate, which means that my rectangular coordinate is this point, root 3 over 2 and 1/2, which is the point that we have been using. Again, our radius for this problem has been 1. So anytime going forward now, whenever we want to find a rectangular coordinate, it's going to be kind of similar to these numbers. So it might have a root 3 in it. It might have a root 2. Just realize the example that I have has the root 2 on the bottom, right? Root 2 over 2, root 2 over 2. So let's come back to our first set of problems that we did, right, with these. And let's actually change a few of them into rectangular coordinates. So I'm not going to do the 1 and the pi over 3 because that comes from our unit circle. So I'm going to do the -3 comma pi. Okay, so let's change this to rectangular. So rectangular. Okay. So again, what do I know? I'm going to say x is equal to my r, which is -3, so it's my original one that I start off with, times the cosine of pi. What is the cosine of pi? That is -1. So negative times the negative gives me a +3. Okay? And then I'll find my y coordinate. So y is equal to -3 sine of pi. All right, sine of pi is 0. So -3 times 0, that means this would just be 0. So my new coordinate is 3, comma 0. Now, if we think about this in terms of kind of like an x-axis and a y-axis, it kind of makes sense that if this was my origin and this was my x-axis, these are my y-axis, that I'd be going over 1, 2, 3, and I'm not going up and I'm not going down. All right, so now let's try with our second point over here. So bam, so we're gonna say 2, 45. So here's our rectangular coordinate. So x is equal to my r, which is 2, and then my sine, or sorry, cosine. So cosine of 45 degrees. So this is 2 times root 2 over 2. So the 2's cancel away, leaving you with just root 2. I would do the same thing for y. So y is equal to 2 sine of 45. So again, 2 times root 2. The 2's cancel away, leaving you with just a root 2. So again, here is our here's our rectangular coordinates. Okay. So let's do a few more, and let's just for these, let's come back to this page. So for these ones, we won't plot or anything. So we're going to find 2 more points, and then change to rectangular coordinates. Okay, if you want to go ahead, you want to plot these as well, by all means, please do so, but you don't have to. Okay, for the 2 points, you have to include, let's say, 1 negative r, so 1 negative r, and 1 negative theta, right? So that will kind of help us. So if you want to do more than 2 points, by all means, go for that. But one of the points you have to have has to have a negative r in it, and one of them has to have a negative theta in it. Okay, so here's our, let's do another example. So we'll call this A. So let's say that the point is 3, and let's start off easy. We'll say 90 degrees. So that'll be the first one. And then for B, I'm going to say 4 comma, we'll start off with another easy one, 3 pi over 2. So go ahead, pause the video now and try these and see if you get the same ones that I'm about to get to. We should for sure get the same rectangular coordinates, but depending on if you kind of put these together, that kind of kills 2 birds with 1 stone. So you might have a little bit different ones than me. All right, so coming back, I need to find 2 points. So I'm going to find my 2 points in red. So again, I kind of just want to make a quick little sketch. So again, if I know that that's 90 degrees, the first one I'm going to go with for the negative r value is, if I know that that's 90, this is going to be 270. So I'm going to go in the opposite direction. So I'm going to say if I go 270, be here, but I want to go towards the 90. So I'm going to say negative 3. Right, so negative 3 comma 270. If my theta needs to be negative, well, I'm going to make that become a negative 270, and I'm going to go towards it, positive 3. Okay. If we wanted to do any other ones, right, you can always email me and check to see kind of if you have the same values. Okay, so for instance, I'll do one more. So if you went, let's say you just went negative 90 degrees. So negative 90 degrees leads you here, but again, you want to be up there. There's the negative 3. So kind of all 3 together. Let's see, I want to change it to rectangular coordinates. So I'm going to say x is equal to 3 cosine of 90 degrees. So 3 times 0, so that's just going to be equal to 0. This will be y is equal to 3 sine of 90 degrees. So 3 times 1. All right, so that means my rectangular coordinates will be my x, so 0, comma 3. So that'll be my rectangular coordinates. All right, for the second one. All right, so r was 4, theta was 3 pi over 2. I just realized I gave you another quadrantal angle. Meant to not give you another quadrantal angle, but that's okay. So again, negative r value. So if I think about this in 3 pi over 2, so that means if I want to go towards 3 pi over 2, but maybe I have pi over 2, so one first angle would be negative 4, and then a positive pi over 2. So if you think about it, these numbers should never really change too much. It should just be a positive or a negative number. If I did a negative 3 pi over 2, so negative 3 pi over 2, again, that leads us right back up here. And then I want to go towards, this one. So again, I want to go away from that. So negative 4, I can also do it that way. I could do just negative pi over 2. That leads me that way with a positive 4. So again, a little bit differently. And then last but not least, my coordinates. So 3 times the cosine of 3 pi over 2 That's 3 times 0, which gives me 0. Y would be 3 times the sine of 3 pi over 2, which gives me 3 times negative 1. So the point would be 0, comma, negative 3. Okay. All right, let's try something a little bit differently. What happens if I ask you this question? So I'm going to say, which polar coordinate represents the same point as this, 3 and pi over 4. So here are your choices. So A is 3 comma 9 pi over 4. B is 3 comma 7 pi over 4. C is negative 3 pi over 4. D, 3, negative 4 pi, or 5 pi over 4, I should say. Negative 3 and negative 3 pi over 4. And F, negative 3, negative 7 pi over 4. So go ahead and pause the video. I'm going to pause the video too to put up another circle so we can see what's happening here. All right, so I popped that up. So again, pi over 4, that's right here, and then going towards it, so 1, 2, 3. So this would be my point that I'm trying to get. So hopefully we have paused the video and tried to figure out which ones are going to work. So I'm just going to walk through all of them. So 9 pi over 4, that means I've gone around the unit circle more than once. So if I think about 9 pi over 4 and I subtract 2 pi, which is the same thing as saying 9 pi over 4 minus 8 pi over 4, that will give me pi over 4. So 3 and the 3 stay the same. So that A is going to work. Okay, negative 7 pi over 4, so that means I'm going to go in the opposite circle. So positive 7 pi over 4 is in the fourth quadrant, which means that if I go negatively, I should be here, which makes sense. And so then I'm going to go towards the 3, so 1, 2, 3. So again, B is going to work, so that works out beautifully. C, 3 pi over 4, so 3 pi over 4 is in the second quadrant no matter what, and I'm going to go away from the second quadrant, which means I'm in the fourth quadrant, so I'm going to say quadrant number 4, so that one's not going to work out. Negative 5 pi over 4, so a normal 5 pi over 4 is right here, but I'm going to go negatively, which means I'll be in the second quadrant, and I'm going to go towards the 3, which means I'm going to be in quadrant 2, not going to work out. Negative 3 pi over 4, so normally this is positive 3 pi over 4, so negative would be here. So it would be this line right here, 3 pi over 4. I want to go away from it, so I want to go towards the pi over 3, so this one is going to work out, which is lovely. All right, negative 7 pi over 4, so we've already figured out that this is negative 7 pi over 4, but this time we have a negative 3, which means I go away from it, so it'll be coming down here, which means it'll be in quadrant 3, so F is not going to work out. Okay, let's try, what happens if I want to go oppositely? So, so let's take the rectangular and change them to polar. Okay, so let's take our first point, and let's say that it's 1, 1, and our theta is somewhere between 360 degrees and 0 degrees. Okay, so what do I know? I know that this is x, and I know that that's y, so I'm just going to say 1 squared plus 1 squared is equal to r squared, so 1 plus 1 is 2. So r is equal to the radical 2. R is always positive. Okay. So now I'm going to set up with my x. So my x is 1 is equal to my r. And then cosine of theta divide cosine of theta, so which is root 2 over 2. So it's positive, so I know I'm in quadrant 1 or I'm in quadrant 4. So I'm going to do the same thing with my other one. So 1. And I do this whole thing, and I know it's positive, so I know I'm going to be in quadrant 1. So where am I going to be at is 45 degrees. So this would be 1, comma, 45 degrees. In the next video, we'll